Hey folks, this is a video on the parts of a hyperbola. So let's take a look at your notes from section 7.2b. The first thing to point out is that I have two different hyperbolas. One of them opens to the right and the left. This one will be the horizontal hyperbola, and the other one opens vertically up and down. So let's go ahead then and just start naming some of the pieces of the hyperbola. A lot of these are going to be familiar since you have already done these in several of your other conic sections. The first thing to note is that my hyperbola has a center, and we call that center HK. Not a big surprise there. The second thing of note is that my hyperbola has two different axes. Remember on the ellipse how you had a major axis and a minor axis? Well, my hyperbola also has two axes, but that's not what we're going to call them. And the first one is called the transverse axis. This is like the major axis on the ellipse. The difference is that a major axis is always longer than the minor axis for the ellipse, but in the hyperbola, the transverse axis is not always the longer axis. It might be a shorter axis. So it's called the transverse axis. The other axis is going to be called the conjugate axis, and it's the one that doesn't even touch my two pieces of my hyperbola. The transverse axis cuts straight through the middle of the two pieces of my hyperbola. The conjugate axis goes in between them, never touching the actual hyperbola graph. Next, let's take a look at something that will be familiar, and that's going to be the vertices. And so you notice here that this piece right here and this piece right here is, these are going to be two vertices. And since I've already uncovered it accidentally, the two dashed lines that you see, these guys are both going to be called the asymptotes. These fence in the hyperbola. The hyperbola is always getting closer and closer and closer to my asymptotes, never actually reaching them, never actually touching them. And then the last thing to point out is that I have a focus. I have two of them actually. So I have two focus points on my hyperbola. Now I want to look at three different distances for you. I actually looked at these three different distances back on the ellipse. These are going to be very similar for the hyperbola. And instead of continuing to add more things to the same picture, I used the other picture to use these three distances. So the first distance to point out to you is going to be the distance that goes from the center to the vertex, and that's always going to be a distance of A. The second distance is the distance that goes from the center to the end of the conjugate axis. I don't have a special name for that point. It's just called the end of the conjugate axis, and that's going to be a distance of B. And then the third distance to point out to you is going to be from the center to the focus point, and that's going to be a distance of C. Now let's take a look at the two pictures and compare them to my standard equations. This time around, you'll notice that the denominators are identical. The A value is always going to be in the positive fraction. And if that triggered something, take a look. I've always got to have a positive fraction, and I'm going to have a negative fraction. Sometimes it's the x fraction that's positive, sometimes it's the y fraction that's positive. But A is always in the positive fraction. B is always in the negative fraction. The way that I tell the difference and match these up with my graphs, whenever x is in the positive fraction, then my hyperbola will open up horizontally or along the x direction. Whenever my y value is in the positive fraction, then my hyperbola will open up in the vertical direction or in the y direction. Just like in the ellipses, I also have my little dude. This equation is only going to matter when I'm dealing with focus points. And then last but not least, I have three statements to make, and I made these same statements back in the ellipse section, because they're exactly the same statements for ellipses as they are for hyperbolas. And that first statement is that my vertices are always going to be A away from the center. My endpoints of my conjugate axis are always going to be B away from the center. And then thirdly, my foci are always going to be C away from the center. And that deals with those three distances that we dealt with on the right-hand picture.